Welcome to Homework Lib.
In the current problem 42.30, we are given that we have a p-n junction diode with a saturation current of 0.95 milliamps whenever at the temperature 20 degrees Celsius. And we are wanting to find the resistance of this diode at given voltages, both for part A, 85 millivolts, and for part B, minus 50 millivolts. And so, knowing what we are looking for, we can start out by converting into the scientific SI unit for temperature, which is Kelvin. So that bumps us from 20 degrees Celsius to 293 Kelvin. It's no longer degrees, it's an absolute unit. And we are wanting to find resistance, which the standard formula for resistance applies here, which is simply V over I, so voltage over current. However, this current depends on temperature and voltage, since we have a diode system here. So our current has a form like this, where I is equal to the saturation current IS multiplied by E to the elementary electric charge, voltage, all over Boltzmann's constant and the temperature. And then we subtract 1, and this is the form for the current at a given voltage and temperature. So then when it comes time to executing this problem, we simply have to plug and chug, because we have saturation current, we have voltage, we have temperature, and these are constants. So we have everything we need. And I'll move to a new page here. If you start plugging stuff in for part A, you get that the R V over I so I will go ahead and put in 85.0 millivolts saturation current, which is 0.95 milliamps. I've already crunched the numbers here. It comes out to something like 3.36 minus 1, which gives you 3.21 ohms. Simple enough. The calculator did most of the work here. And similarly for our second one, you now end up with, well, you don't care about the negative here, but you end up with a negative in the denominator. So if we have negative 50 millivolts all over 0.950 milliamps multiplied by E to the minus 1979 minus 1. Negative down here cancels out the negative up here, which leads to minus 104 ohms. And that's all the problem asks for. So we can stop there with our solution. Oh, this should not be a negative. Whoops. Yeah, obviously you can't have a negative resistance. Finished. Nice.